Hello everyone, welcome to my math channel. This is Mr. Mahmoud explaining Algebra 2, Chapter 6, Lesson number 8, Natural Logarithms. Let's begin by the natural base function. The function f of x equals e to the power of x is used to model continuous exponential growth. The function f of x equals e to the power of negative x is used to model continuous exponential decay. The inverse of a natural base exponential function is called the natural logarithm. This logarithm can be written as log x to the base e, but is more often abbreviated as ln x. Here in this figure, the function f of x equals e to the x is the exponential function representing exponential growth. That's why it's increasing function as x going from left to right. The inverse of this function is called f of x equals ln x, the natural logarithm function, and it's a reflection of the exponential function along this line. This line is the line y equals x. Also the same here, the exponential function that represents exponential decay, it's f of x equals e to the negative x, and the red line represents the ln function, which is f of x equal negative ln x. And also both functions are inverse of each other and reflection on the line y equals x. Example 1. A. Write an equivalent logarithmic equation for e to the power of x equals 23. First, we know that e is the base and x is the power equals 23. So we can change it into log 4 as we learned before. This is log to the base e and the power should be the answer. So log 23 to the base e equals x. Now we don't really write log to the base e, we write it as ln. So this is ln 23 equals x. Another method we can do it this way. E to the x equals 23. I can take ln for both sides, so ln e to the x equals ln 23. Since we know that ln and e are inverse functions, so they cancel each other, so x equals ln 23. So the answer is ln 23 equals x. Now write an equivalent logarithmic equation for e to the power of 4 equals x. E is the base and 4 is the power, so log, we put here e at the base and we put 4 in the answer, and it will be log x base e equals 4. Another method, as I told you, so we have e to the 4 equals x. We can take ln for both sides, so ln e to the power of 4 equals ln x. Ln will vanish the e, so 4 equals ln x, or ln x equals 4. This is the accurate answer. This is your turn to solve. Pause the video and try to choose the accurate answer, and you will find it D. Why? Let me tell you. E to the power of x equals 15. I'll take ln for both sides. I prefer this method, so ln e to the power of x equals ln 15, so ln and e will go away, so x equals ln 15. What is e to the power of 4 equals x in logarithmic form? Yes, it's b. E to the power of 4 equals x, so ln e to the power of 4 equals ln x, so 4 equals ln x, or ln x equals 4, so b is an accurate choice. Now write ln x equals 1.2528 in exponential form. Means I give you the logarithmic form and you will give me the exponential form. So let's get it back. We know that ln, it's log to the base e, so let's write it first as log x to the base e equals 1.2528. Now we know that e is the base and this is the power, so we can say x equals e to the power of 1.2528. Another method, this is ln x approximately equal 1.2528. So I'll take base e for both. Base e for both means it will be this way, e to the power of ln x approximately equals e to the power of 1.2528. Now since we know that e and ln are inverse functions, so they vanish each other and x remains. So x approximately equal e to the power of 1.2528. So this is the final answer. Write ln 25 equals x in exponential form. So first we know that ln is log to the base e, so we'll write it as log to the base e, 25 equals x. E is the base and x is the power, so we can easily transform it into exponential. 25 equals e to the power of x. We can also do it this way. This is ln 25 equals x. I will take base e for both, so e to the power of ln 25 equals e to the power of x. So I can cancel e and ln, they are inverse functions. So 25 equals e to the power of x, or e to the power of x equal 25. This is the final answer. This is your turn to solve. Write ln x approximately equal 1.5763 in exponential form, and you will find the accurate answer will be, yes, it's B. As I told you, I like this method, e to the power of ln x approximately equal e to the power of 1.5763, so e and ln will cancel each other, so x approximately equal e to the power of 1.5763, which is B. Write ln 47 equals x in exponential form. Pause the video and try to choose the accurate answer. You will find it A. So we have here ln 47 equals x. I'll take e to the power, so base e power ln 47 equals base e power x. E and ln will cancel each other, so 47 equals e to the power of x. Write 4 ln 3 plus ln 6 as a single logarithm. So how can we write it as a single log? It's very easy. Just remember that the properties of logs are also applicable for lns. So when you have ln xy means ln x plus ln y. This is the product property, and also the quotient property, len x over y equals len x minus len y, and also for the power property, len x to the power of n. This n will come here in front of len with multiplication, so it's n len x. So the three rules of logs are applicable for lens, as lens are also logs. So now we will use these rules. We have 4 len 3 plus len 6. I can take this 4 up to the power, reversing the power rule. So it will be len 3 to the power of 4 plus len 6. Now we know that the plus will come back to multiplication. So it's len 3 to the power of 4 multiplied by 6. And we can evaluate 3 to the power of 4, 81 multiplied by 6. This will give you len 486. So we succeeded to express the whole expression as a single log or single len. Now write 2 len 3 plus len 4 plus len y as a single log. So what you are going to do is take this 2 to the power again. It will be len 3 to the power of 2 plus len 4 plus len y. Means you need to be sure that nothing in front of len. Now we can take len, and all of plus sign will be multiplication sign. So len 3 to the power of 2 multiplied by 4 multiplied by y. 3 to the power of 2 is 9 times 4, 36. So len 36y. We succeeded to express this expression as a single log or a single len. So the answer is len 36y. Now this is your turn to solve. Pause the video and try to choose the accurate answer, and you will find it D. Let me show you why. The problem is 4 len 2 plus len 3. Let's take 4 to the power. So this is len 2 to the power of 4 plus len 3. Now we can get the plus into multiplication, so take 1 len, and this will be 2 to the power of 4 multiplied by 3, and this will be len 2 to the power of 4 is 16 multiplied by 3, 48. So len 48 is the accurate answer. Let's write 3 len 3 plus len third plus len x as a single log. Pause the video and try to choose, and you will find it B. Let me show you why. This is 3 len 3 plus len third plus len x. Take this 3 to the power, so this will be len 3 to the power of 3 plus len third plus len x. Now we can take len back into the multiplication, so plus plus will be multiply. So 3 to the power of 3 times third times x. And you can notice that I expressed all this len as one len. So 3 to the power of 3 is 27. 27 times 1 over 3 is 9. So this will be len 9x. That's why B is the accurate choice. By this, my dear students, we come to the end of this part for today. Till we meet again in part 2. Goodbye.